In this wee video, we're going to look at differentiating sines and cos. So you're given this table in your exam. So it tells us that sine AX, now if it's just sine X is 1, so that becomes 1 cos 1x. So in other words, the derivative of sine X is cos X. Derivative of cos, A again is 1, so it's minus 1 sine 1x, which is just minus sine X. So try and remember those two. So when you're taking your derivative of any function, you can use that wee table. Now here we've got 2 sine x, so the 2 stays where it is, and the derivative of sine x is cos x, it becomes 2 cos x. This one here, we want the derivative of f dash x, and when I do that one, there's a 5 there, leave the 5 sitting there. The derivative of cos x is minus sine x, but always tidy that up, so that would become minus 5 sine x. Next one, you've got two functions together, but that makes no difference. You do each one separately, the way you did a whole list of adding and subtracting x squareds and x's. So we've got a 7 there. The derivative of sine x is cos x. Don't need a bracket because it's straight to cos x. Then I've got a minus 3. Derivative of cos x is minus sine x. I'll put that in a bracket so I can tidy it. So that gives me 7 cos x plus 3 sine x. Okay, again, I've carried the wee table through. This time we've got numbers in front of x. So when we've got a number in front of x, then it means that that number has got to be multiplied. Okay, so if there's a number in front of x, it comes to the front and we multiply by it. So there it's there. Right, so the first one here, we've got part A, f dash x, and we've got sine 3x. There's a 3 in front of that, so it becomes 3 cos 3x. Angles must always stay the same. Part B, we've got y is equal to cos 2x, so the derivative will be dy by dx, and that's going to be 2 times, and cos gives us minus sine, and it's 2x. So tidy all of that up, becomes minus 2 sine 2x. Next one, part C, we've got fx, so it's f dash x as a derivative. There's a 5 in front of sine x, so that becomes 5 cos 5x. Next one, part D, we've got y is equal to cos 4x, so it's dy by dx. The number in front of the x is 4, so it's going to be 4. The derivative of cos is negative sine. Angle's got to stay the same, so 4x stays there. Tidy it up is minus 4 sine 4x. Next one, part E, we've already got a 2 there, so that 2 stays, so just write it down, and then we've got a 3 in front of the angle, so it's 2 times 3, and the derivative of cos has got to be minus sine, so it's minus sine, and the angle is 3x. So that gives me an answer of minus 6 sine 3x. Last one there, part F, we've got y, so it's dy by dx, and that derivative, we've already got a 2 there, so we'll leave it. The number in front of x is 4, so it's 2 times 4, and the derivative of sine is cos, and it's 4x, because the angle's got to stay the same. Tidy it up, gives us 8 cos 4x. All of these ones are similar. We've got the number in front of x, so that first one, part A, we'll leave the 3. We know there's a 5 in front of that x, so it becomes 5 times 3, and the derivative of cos is minus sine, so it's minus sine 5x. So tidy all of that up, gives us minus 15 sine 5x. Next one, part B. So part B, we've got fx, so it's f dash x, and we've got a minus 2, so we'll write the minus 2 in there. And then we've got cos, there's a 2 in front of that x, so that 2 goes in there, and the derivative of cos is minus sine, so it's minus sine. The angle stays the same, and that's 2x. So that gives me 2 minuses make a plus, 2 2s are 4, so it's 4 sine 2x. Next one, part C. So for part C, we've got f dash x, and we've got a minus 2 sitting in there, so that stays. We've got a 2 in front of the x, I've got to multiply by that, and the derivative of sine is going to be cos, so it's cos 2x. Tidy it all up, becomes minus 4 cos 2x. Next one, we've got a wee chain of a couple of them there. So we've got part D, and there's two bits to it. We just do them together. So do y by dx is equal to the derivative of 3 cos 5x. Leave the 3 where it is. The number in front of x is 5. And the derivative of cos is minus sine. And the angle stays the same as 5x. Then we've got a plus. We move on to the next term. The angle, the number in front of x is 2, so it's going to be 2. And the derivative of sine is cos, so it's 2 cos 2x. Tidy it all up. Minus 5 times 3 is minus 15 sine 5x. And we've got plus 2 cos 2x. Next one, part E. We've got f dash x. And we have 2 sine 4x. So number in front of the x is 4, the 2 stays where it is, so we write the 2 down, we times by 4, and the derivative of sine is cos, so it's cos 4x, and then we move on to this next term, so there's minus 3, put in a wee bracket, number in front of the x is 2, and the derivative of cos is minus sine, so it's minus sine 2x. Tidy all of that up, gives us 8 cos 4x, minus the minus make a plus, and 3 2s are 6, so it's going to be 6 sine 2x. Okay, and the last one there is part F. So for part F, we've got f dash x, and we want the derivative of cos x. Now we know the derivative of cos x is minus sine x. Then I've got a minus 3, I'll write that down. And then I've got a 5 in front of the x, so I'm timesing that by 5, and the derivative of sine is cos, so it's cos 5x. Tidy all of that up, gives us minus sine x minus 15 cos 5x. Now, these ones look more complicated, but they're not. The only important thing is the number in front of x. These things stay the same, so it's only these numbers here that are important. Okay, that's all we're worried about. So when I do part A, we've got dy by dx, and I look at the number in front of the x is a 2, so it's 2. The derivative of cos is minus sine, and the angle stays the same, so in that bracket you've got 2x minus 3. That always stays the same. So tidy that up, gives you minus 2 sine 2x minus 3. Next one, part B. So for part B, we've got f dash x, and the number in front of the x is 4, so we do 4. The derivative of sine is negative cos, so it's minus cos, angle stays the same, which is 4x plus 2. Tidy it up, gives you minus 4 cos 4x plus 2. Next one, part C. I've got a 5 in front of the x, so f dash x becomes 5 times, and the derivative of cos is minus sine, so it's minus sine, and the angle is 5x plus 1. So that equals minus 5 sine 5x plus 1. Next one, part D. We've got y is equal to sine, and in the bracket, so number in front of sine is just a 1. So what we do is we write our dy by dx, and the derivative of sine is cos, so it becomes cos, and it's going to be x plus pi over 3. The next one, part E. The only important thing here is the number in front of your x again, irrelevant what this last bit is. So f dash x, we're going to multiply by that 3. And the derivative of cos is minus sine, so it's minus sine, and the angle stays the same, 3x minus pi over 3. We'll tidy that up to give us minus 3 sine 3x minus pi over 3. Next one we've got is part F. So we've got f dash x. We've got sine, the number in front of the x is 2, so it's going to be 2. Number in front of x is 2, so it's going to be 2. And the derivative of sine is cos, so it's going to be 2 cos. And the angle is 2x plus 3 pi over 2. Don't need to tidy that up, that's fine. Next one, part G. So I've got y is equal to sine x squared plus 1. So for that one, we've got the y by dx, and the derivative of sine is cos. Angle stays the same. This one's a wee bit different because it's not just a 2x or a 3x, so we multiply by the derivative of that, which is 2x. And basically that's what you were doing with all of them. Like the 2, derivative of that would be 2. That's where the 2 comes from. The derivative of this 4x plus 2 is 4. That's where that comes from. So that then gives me 2x cos x squared plus 1. The next one we've got is part H. So fx is equal to cos, and the whole thing in the bracket. It's not just an x with a number, there's an x squared. So we'll do the derivative of cos is minus sine, so f dash x is equal to minus sine. The angle is 2x squared minus 2, multiplied by the derivative of that bracket, so we're times that by 4x. So that's equal to minus 4x sine 2x squared minus 2. Last one there is part I, and for that one in the bracket it's not just 3x or 4x, we've got an x squared again, so it's similar for that one. These ones would be quite hard, okay, but you can learn how to do them. So we've got f dash x, and we have got the negative cos, so we'll leave the negative there. The derivative of cos is minus sine, so it's minus sine, and the angle is 3x squared minus 2, and we're going to multiply that by the derivative of that bracket, so we're multiplying by 6x, tidy all of that up, and that gives you 6x, 2 minuses make a plus, so 6x sine 3x squared minus 2. Now, these ones here, sine cubed, cos squared, all of those ones, they're a wee bit more tricky. So we've got to put a bracket in. So for one part A, that really should say fx is equal to, and it's sine x all to the power of 3. So we treat that just as though that's like an x squared or whatever in there. So the rules for taking the derivative of anything with a bracket is multiply by the power, take 1 away from the power, so that becomes 2, and multiply by the derivative of the bracket, and the derivative of sine is cos x. And we'll go back and fill that bit in for the bracket, so that becomes 3 cos x times sine squared x. Next one, part B, again, we've got to put the bracket in, so cos squared x should really be written like that. The derivative, we know the rules are multiply by the power, take 1 away from the power, so 2 times your bracket to the power of 1, and multiply by the derivative of your bracket. Derivative of cos is minus sine. I'll go back, fill in the bracket, which is cos x. So that whole thing comes out to be minus 2 sine x times cos x. I'm going to do a wee extra bit in that one. So that bit there reminds me of something. That's on your information sheet. And on your information sheet, that would be sine 2x. So that could be minus sine 2x. You weren't asked to do that, but always look out for wee things like that, because sometimes you can get wee marks where you have to prove something equal to an expression. Right, next one, part C. So for part C, we've got fx is equal to, take your power of 5 out, so it's sine x to the power of 5. Multiply by the power, take 1 away from the power, so f dash x gives me 5, and the bracket to the power of 4, multiply by the derivative of the bracket, derivative of sine is cos x. I'll go back and fill in the bracket, so that gives me 5 sine 4x times cos x. You can rearrange them if you want, but you don't need to. Next one, part D. So part D, we've got y is equal to cos to the power of 7x. So that's going to be y is equal to cos x to the power of 7. So dy by dx, same rules, multiply by the power, take 1 away from the power, and multiply by the derivative of your bracket. Derivative of cos x is minus sine x. So you need a wee bracket when there's a minus sign there. Tidy it up, and that gives you minus 7 cos to the power of 6 of x, and that's also times sine x. Okay, that's most of them done. I'm not doing the other ones because they're all exactly the same. Okay, here we've got a combination. So I'm going to prepare this one. So fx is equal to sine x to the power of 2 minus cos x to the power of 2. So we'll do them in stages. Multiply by the power, take 1 away from the power, multiply by the derivative of the bracket. Derivative of sine x is cos x. I'll fill sine x in there. Then we're on to this minus, and we multiply by the power, so it's minus 2 cos x to the power of 1, and the derivative of cos x is minus sine x. So a wee bit to tidy up there. That gives us 2 sine x times cos x. That minus and that minus make a plus, so it's plus 2 sine x cos x. Now, those two terms are exactly the same. So I've got 2 of them, I've got another 2 of them, which is 4 of them, so it's 4 sine x cos x. Next one, part B. So for part B, we've got y is equal to cos x squared minus 2 sine 2x. So multiply by the power, take 1 away from the power, so 2 times cos x to the power of 1, multiplied by the derivative of your bracket. Derivative of cos x is minus sine x, and they're multiplied. Then I move on to this minus 2 sine 2x. The number in front of x is a 2, so I'm going to be multiplying by 2, so that becomes minus 2, and then 2 from the x. Derivative of sine is cos, and the angle is 2x. So that whole bit there is 2 times minus 1 is minus 2 sine x cos x, and then minus 4 cos 2x. Now, this is the last lot of these derivative ones. So we've got to find f dash pi by 4 when fx is 2 sine 4x. So we've got fx is equal to 2 sine 4x. So the number in front of x is a 4. So f dash x is going to be multiplied by that 4. So it's 2 times 4. And the derivative of sine is cos. So it's cos 4x. When I tidy that up, I get 8 cos 4x. Now they want me to find f dash pi by 4. So f dash pi by 4 is going to be equal to 8 cos 4 times pi over 4. That 4 and that 4 will disappear. So I really want to evaluate 8 cos pi. Now remember, pi is 180 degrees. So there's my cos graph, starting at 1, down to minus 1, back up to 1 at 360 degrees. Pi is 180 degrees. So there's 180 degrees in there, and that's at minus 1. So that's going to be 8 times minus 1, which is minus 8. Next one we've got is part D up there. So for part D, we want to find f dash pi by 4. We'll get fx is equal to 3 cos 2x. The number in front of x is 2. So f dash x is going to be 3 times 2. The derivative of cos is minus sine, so it's minus sine 2x. Tidy all of that up, it gives you minus 6 sine 2x. We want to find f dash pi by 4, so f dash pi over 4. That will be minus 6 sine 2 times pi over 4. That 2 and 4 will cancel, and that would give us pi over 2. So I really want to evaluate minus 6 sine pi over 2. Now pi over 2 is the same as 90 degrees. So when I take my sine graph, there's a sine graph there, and I want sine 90. 90 degrees is in there. So sine 90 is 1, so that becomes minus 6 times 1, which is minus 6. The last two that we've got here, we want to find f dash 3 pi by 4 when fx is equal to, and it's cos squared x, so cos x to the power of 2. Rules again, same rules, multiply by the power, take 1 away from the power, and multiply by the derivative of your bracket, and the derivative of cos x is minus sin x. So when we tidy that all up, we get minus 2 cos x times sin x. I want to find that when it's 3 pi over 4, so f dash 3 pi over 4, and that would be equal to minus 2 cos 3 pi over 4 times sin 3 pi over 4. Now for this one, 3 pi over 4 is 3 times 180 degrees divided by 4, which turns out to be 135 degrees. Now 135 degrees is one of those angles that could be your exact value, and that's one of the ones that stems from 45 degrees, and it's in quadrant 2. 180 minus 45 is 135. So to evaluate that, we're really looking at cos and sin of 45. That minus 2 stays, and I want cos 3 pi over 4, which is cos 45. Cos 45 is 1 over root 2, but cos is negative. Thinking of your cast diagram, cos is negative in quadrant 2, so it's minus that. Then we've got to multiply it by sin 135. Now sin 135 is the same as sin 45, which is also 1 over root 2. Now we've got to decide whether it's positive or negative. In quadrant 2, sin is positive, so it's just 1 over root 2. So when we multiply that all out, 2 minuses make a plus, so it's 2 divided by root 2 times root 2 is 2, so the whole answer to that turns out to be 1. So you could be given something like that as an exact value, okay? And I did a wee video going through all of them earlier, so maybe refresh your memory with that. Right, last one here, fx is sin squared x, so it's sin x to the power of 2. So when I take the derivative, same rules, multiply by the power, take 1 away from the power, and multiply by the derivative of your bracket, and derivative of sin is cos. So that gives me 2 sin x times cos x. So that is equal to 2 sin pi over 6 times cos pi over 6. Now we've got to think about what pi over 6 is. 180 divided by 6, so we're really talking about 30 degrees. So I've got 2 times sin 30 is equal to half. Cos 30 is root 3 over 2. Multiply straight across the top gives us 2 root 3 over 4. But of course, those 2's could have cancelled, so that's going to be divide top and bottom by 2 is root 3 over 2.